Hey, hi. We'll go step wise. So first I'll go to the project folder. Okay. To run your project, what are the steps involved? What you can do, you can go to your project folder, whatever project folder I have given to you, and then you just have to simply right click anywhere in the free space, and here you have to select open in terminal. Okay, this is the one of the way to run the project. Okay, then here you have to type Python project. Okay, this command, and you have to hit enter. Okay, this is the one of the way. Second way is you have to go to your this address bar, you have to select it, you have to remove this address bar. Here you have to type cmd and hit enter. Once you hit enter, here you have to then again type same command python start.py. You can simply type as and hit enter and hit tab, it will automatically suggest you. Okay, and will give the name, and you have to type as it is this file name. Okay, and third way is you can go to VS Code. Okay, you can go to file and then you can go to open folder, or here you can select your project folder. Okay, whatever path you have, and you just have to paste your project folder path here. Then I suggest download VS Code. With your VS Code you will be the command will be visible to you. Okay, the files and code. And then here you have to do the same, you have to go to your terminal, and here you have to type new cmd. Okay, and here you have to type uh, python same command. Okay, that's the only thing, we are accessing cmd from this terminal. Okay, there is nothing change. Okay, but I suggest go with this cmd one. Okay, this is the one of the best way and fastest way. Okay, and to check the source code, you can download VS Code and you can check the source code. Okay, so this way you can run the project. Okay, and once this project will get load. Okay, so here you can type the username as the admin, and the password will be pass123. Okay, like that. And then you have to click to this start system. Okay, and then system will start. Okay, and then you can pass image if you want to predict from image. And I have given you some test data, like if you go to test videos, here I have given you some test images as well as videos, you can upload your own. Okay, and here you can pass the video and image. Okay, similarly if you click to video, and then you have to select the video, and it will open multiple panels uh, like it will give the prediction, right? The steering wheel, we have done the steering wheel simulation, which is making prediction whether we want to take left or right. Similarly we have integrated drowsiness system, so it will start a camera and start detecting drowsiness. Okay, and if any alert found, like if so, what are the models we have implemented? Okay, so we have implemented multiple modules like drowsiness system. So it will continuously monitor your drowsiness, and if you found drowsy, it will play alert. Okay, and if you found drowsy for certain time, like 10 seconds or multiple times you found same drowsy, then it will send alert email to your family member. Whatever email ID you have mentioned, will send the email to that key. This person found in drowsy, and will send alert. This is one of the thing which we have done. Second thing is steering wheel simulation. Steering wheel simulation. So for this we have trained a CNN algorithm on a certain data set, and from there we are making the prediction based on the lane angle. We are just showing the steering wheel angle. Okay, similarly la- lane detection. Okay, we are also performing lane detection. We are just demonstrating the lane. So let me show you the demo. I have given you demo video, right? So like that it is working. So let's go to the coding part, key what we have done and how these things are working. Okay, so for lane detection. Okay, see for lane detection I will give you a separate video. Okay, so you can check that key how we are doing that. Okay, second thing is for steering, we'll go for this steering wheel detection. Here we have used CNN algorithm. Basically we have used one of the data set. What we have done, let me tell you in simple way. Okay, so what we have done, we have collected a data set which having roads image. Okay, the roads image. Suppose let me go to the data set. This is the data set. I will give you the link. Okay, suppose if I open any image, so here you can see. So here having the different roads images just like this. Okay, and just like it is almost 40 50 thousands of images. Okay, so it has multiple images, and the developer who have developed this data set, they have also created one data.txt file where they have mentioned the file name and the angle, what angle we should carry for the training, that they have mentioned. Okay, so what we have done, we have took this dataset images, we have we have done some pre-processing on image, we are just passing image to algorithm, and we are also passing the angle to algorithm. See, this is the input image, this steering angle should be. So what we are doing, we are just passing image to algorithm and the angle as a, we are considering x as a images, y as a angle. Okay, and we are just passing it to CNN algorithm, and then algorithm is doing internal training, and based on this training I go do some research here, what is CNN algorithm, how CNN algorithm works, how max pooling layers work, batch processing and all. Okay, and to view the source code for this training purpose, okay, you can go to this project, and there is a notebook folder, so you can go to notebook folder and there is a same driving file is there. Okay, so this is the code for the same. Okay, so if you see, so here we have basically used Google Colab. So what is Google Colab? Google Colab basically a platform which is provided by Google for it is a kind of online computer or system. So it is freely available, like we can use GPU, which is T4 GPU. Okay, so we can achieve good performance, and we have used Google Colab. Okay, and we have connected our drive, the same drive which I have uploaded a data set. Okay, and then here we are loading the data set. As see here, you can see we have loading the data set images and the data.txt file. Okay, so we are just loading all this, and we have just resizing the image into 10 by 10, 100 by 100 pixel, and we are just converting RGB image into HSV. So what is HSV image? HSV image is nothing but colorful kind of image. Okay, HSV image. HSV image is look something like this. Let me show you. Uh, something like this. Basically, it basically classify the image into more aged format. Age means like this. Okay, see this is the one of the image. Okay, so if you see here, you can more lines are visible. Okay, so based on these lines, like like a CNN algorithm can able to identify the features. Okay, so that angle should be predict properly. Okay, so like that. So here this is the simple pre-processing we are doing and resizing into 100 by 100, and this is the load function. So we are loading the data set, like the angle and images into x and y, and then we are storing the into the feature and labels. Okay, and this is our architecture which we have defined. We have used multiple convolution layer, activation layer, max pooling layer. We have simply defined these six layers of convolutional. And what is CNN layer? If you do some research, CNN layers, what exactly it do? It basically used to identify the features. What is feature? Suppose let me give you a best example. Easy example. Say suppose this is the horse image. Okay, zebra image. So how do we got to know that this is zebra image? Based on color pattern, based on key it has four leg, kind of tail, right, and the pattern of color, right. So these are the features, right. So CNN algorithms do the same. It's basically help to identify the features from input image. Okay, so for such we have used the convolutional layer, and for max pooling is something kind of normalization. Okay, and like that we have implemented the uh, feature architecture. Okay, and then we are loading, once the this data pre-processing done, we are loading the data set. Okay, and then we have dividing data into 18 into 20 ratio, like we are testing taking 20% data as a testing and 80% as a training. Okay, and then we are training the model, and we have just took 5 epochs because the data size was huge. Okay, it has almost 15,000 emojis. So Colab was throwing out of memory exception because it only provide 10 or 12 GB of RAM. Okay, so it was not accepting. So that's why we have took very small batch size and very small number of, but still we have got a good accuracy, 87% with the accuracy graph. And these are the rest matrix. You can use this matrix into the report to mention. Okay, basically we are used two algorithms. One is this CNN one which we have trained by own, so you can use this matrix and you can create a table and put into report. Okay, and second algorithm which we have used, so this is the about self-driving car. Okay, so whatever wheel angle is showing, like taking left or right, or it is moving, right, automatically simulating. So this is done by this algorithm, and this is how we have trained the algorithm with this data set and making the prediction. Okay. And the second thing which we have done, we have also done distance estimator, right? Distance estimator. Okay, so for this we have used YOLO algorithm. Okay, so you, for the YOLO matrices, you can mention two types of matrices uh, in the report. One is this one, and second one is you can use the YOLO one. Okay, so I have given, I will share you this PDF link of the YOLO official. Okay, so if you want to get any matrice, so just if suppose you want to get F1 score, so just type F1, so you will get it. So F1 score is 5.9, right? And similarly, if you want to get precision, so you can get any type of uh, matrices from here. Okay, so you can put this in your report. So for matrices we have around 57%. Okay, precision, so like that you can get it. Okay, for recall is also there. Okay, so for recall you will get it from normal internet. You will get the YOLO matrices. Okay, it's not a big deal. Okay, or you can get it, it's up to you. If you want to put in your paper, you can put. Otherwise we can put this. This is our own. Okay, so it's more important. Okay, so you can put this one. Okay, and see, for YOLO, see, for distance estimator, how exactly it is working. See, YOLO, if you search about YOLO algorithm. Okay, so YOLO is basically, see, YOLO is an object detection algorithm. It basically help to detect the object. Ki whatever input image we pass, it will detect ki what type of image it is. So it is able to detect 80 types of object. Okay, so what is 80 types of? Ki it has person, car, bike, truck, etc. So it is almost, it can detect 80 type of object. Okay, so if you want the code. See, for distance estimator, I have created one. I have created separate file for each. Okay. See, this is the distance estimator file. Okay. So here, what we are doing. See, here we are doing. Here first we are loading the YOLO architecture. So we have created a folder called YOLO. Where it is, yeah, YOLO backend. So here we have the YOLO model. Okay, we use the official code, and we are just making the object, and we are just processing the input video, whatever input video we will pass. Okay, and we are just processing one by one. Okay, and it will help to detect the uh, vehicles. Okay, so if you go to see, this is the result image. Okay, and this is the YOLO detector object. Okay, so there is a function which I have created, detect image. So we are just passing the image, and here we are just identifying the object. So this is the official code. Okay, so with this it is identifying the object. Okay, and for distance estimator, wait, for distance identification, yeah, here is the code for distance identification. Okay, so this is the, see, this is the something which I have created. So if you want to test directly, so you can directly do that. Okay, but for the distance identification, here is the code. Okay, here I have integrated all the models like lane detector. uh, I'll tell you one by one. Okay, for the lane detection I will give a separate video, so you can refer that. Okay, so see, this is the estimator. Wait, I have to find the code key where we are doing the distance. Sorry. So basically, where is the code for the distance? Basically, there is lots of code, so it is getting mismatch. Okay, just a second. It is calling me again and again. It's supposed to be here. So yeah, actually, I was just looking for this. set of code only. So actually the code is in the below of this. Okay, so yeah, so this is the function detect image, so where we are just passing the in frame. Okay, so this frame will first detect the number of object, and then we are just doing the processing key, where first we are detecting whether it is what type of object it is, whether it is a person, car, or like that. Okay, because we want just this type of category, so we there is no mean of detecting trees, chairs, like that, right? So we want these features only, so we are detecting these classes only. And then what we are doing, applying this formula. So what is this formula? So basically, see, generally the focal f, what is f is nothing but a focal length. Okay, generally the normal camera focal length is one एक minute, just a second, let me hover this. Okay, so the general focal length is 250. Every camera has 250. Mostly the higher lenses having different, but mostly it's 0. If you also see your mobile camera, it has 0.25. That is nothing but 0.250. Basically, this code we have got from this particular formula we got from in internet. Okay, so what we are doing, we are first identifying the height. Height means what? See the this is the car. Okay, so if you draw this kind of a box. Okay, so see, whatever height of this is nothing but height. Okay, so we are, what we are doing, we are just uh, taking this height and multiplying with a focal length and dividing the absolute value of height. Okay, so then we will get the data into meters. Okay, and then converting into feet, we are converting into divide by 12. So this way we are identifying the height or a distance between from our vehicle to the next vehicle. Okay, and if it is less than 10 or 15, then it is showing the message alert, and like that. Okay, if it is not, then it is not showing the alert or not playing anything. Okay, and it is drawing the rectangles and all. Okay, so this way we are identifying the distance. Okay, so just understand the rough concept. No need to learn line by line code. Okay, so just the concept is key. We are identifying the object, and then we are identifying the height, and then we are applying that formula, and based on that, whatever result we will get, we are taking as a uh, okay, we are just taking as a fit. Okay, so this way we are doing this for the distance estimator. Okay, and for a wheel is also let me explain a wheel code as well. So if you go to algorithm part. Okay, so there is a code detect video, where we are passing the video. Okay, so what we are doing, so here we are loading the model, and these are the frame rate we are taking, and we are loading the steering wheel image. Okay, and then we are opening frame by frame the video, and then we are just making the prediction from the autopilot model, and we will get output as a steering wheel, and based on the steering wheel we are just making it smooth, and we are just rotating the steering wheel image into that particular angle, whatever angle has predicted into that. Okay, and then we are showing it. Okay, and like that we are first processing the steering wheel, then we are checking the estimate distance between the vehicles, and then we are identifying the lane. Okay, so lane is something, uh, just it is drawing the line on input image. Okay, so like that, we are working on the steering wheel, uh, vehicle detection, and distance estimator. Okay, now let's go to the this part, drowsiness system. Okay, so for drowsiness. Okay, for drowsiness we have used delib algorithm, delib and OpenCV. So what is DLEAP algorithm? If you Google it, okay, DLEAP is a basically very advanced algorithm. Okay, DLEAP landmarks. Okay, if you search DLEAP landmarks, so you will get this kind of image. Okay, so what is this image? See, DLEAP basically it helped for face detection. It helped to detect the face as well as the landmarks of face. If you see, so it is nothing but 64 landmarks. So it is has been detected by DLEAP. Okay, so we just have to pass the input image to DLEAP algorithm, and it will give output as a this and also landmarks. Okay, so what we are doing, we are just passing the user image, the user who is driving, okay, and we are just passing the input image and deliver algorithm giving the all 64 landmarks, okay, but we don't have to take all the 64 landmarks. We just have to focus on these landmarks. These landmarks means the left eye landmarks and the right eye landmarks, okay. And then what we are doing, then we are identifying the distance from this point to this point, okay, and from this point to this point we are identifying the distance, height of these landmarks. Similarly, we are identifying height of this right eye as well, okay. We are just identifying the height and we are just validating if this height is less than 0.2 or 3, it's configurable, it's depend upon laptop camera and all. So if in generally take it as a 0.3, if you make it as small, then we have to close our eyes more, okay. And if you make it big, then if as much eyes will open, it will detect as a drowsiness, okay. So generally it is 0.3. So if this height is less than 0.3, that means we are considering as a drowsy, otherwise we are considering as a normal, okay. So if you want to check the code, then you can go to this start drowsy function. So this is the function, this is the file, okay. So here we are just initializing some variables, okay, and some alert audio, okay, and we are defining the threshold values of zero point 0.3, and we are loading some front we have used har cascade for face detection, okay. So if you see, so this is the formula where we are identifying the distance. So what we are doing, we are just getting the landmarks. I told you the landmarks, right? Okay, these landmarks. So we are just getting these landmarks from the delete 64 landmarks, and we are just identifying ER value, height value from this ABC value, okay. And then we are creating the object of delete algorithm. This is the model for delete, okay. And then we are just extracting left eye, right eye, okay. And then we are processing image one by one. I have mentioned comment as well, so you can read. And then I'm not going like completely line by line because it's almost 2003 lines, so I can't explain each and every. Just explaining you the concept, okay. And then we are detecting the face, and then based on left eye, right eye, we are calculating the eye ratio of left eye and right eye, and then we are validating if ratio is less than this threshold value, then showing the alert and the drowsiness detection alert and playing the audio, okay. Otherwise it is not, it is showing as a open, okay. And to configure your email and this threshold value, so what you can do, you can go to this constant value, you can mention your email address to get the alert, and you can also mention your name, okay. And you can also uh, uh, set the limit means ki if this number of times drowsiness found, then send the alert, otherwise not. So I suggest for demonstration keep it as a 30, and for threshold value keep it as a 3. 3 means if you open more eyes, then it will take as well take as a drowsiness. If you make it as a zero point 0.2 or 0.1, then you have to close your eyes, you have to completely close your eyes, okay. So play around this, okay, you will get it, okay. So like that, yeah, configuration I have given you, so you can do the change the configuration, okay. So yeah, so this is about the all modules, okay, which we have implemented, okay. So now let me check the recording is working or not. Yeah. So now let's go for the front end part. See, you used to see this UI thing, right? So how we have done? So basically for UI implementation, we have used one software called Page Builder. So basically, Page Builder is a drag and drop software which is available in Python and developed by some developer. Okay. So in this with this particular tool, we can directly create the UI. So how we create the UI? See, suppose this is the screen which I wanted to create. So okay, suppose I want to create something this kind of screen. So what I can do, I can simply go to my page builder, and whatever thing I want, suppose I want button, then I can click to button widget and then I can place it here. Similarly, I can click it here and place it like this. And I can also select the image from this side menu. I can select the background color, image, anything I can do from here. And with this, I have created the UI like this, okay, from drag and drop. And suppose I have completed the UI part, now I want the code, okay. So what I can do, I can simply click generate Python, and there is a call function. There's a option generate Python UI. You can click here, you can save the file name, and then you will get the complete code. So if you see our code, so it is also similar like this only, okay. So it automatically generate the UI code, okay, based on our created UI, okay. So if you go to your code, you will also able to see similar kind of pattern of the classes and format. Okay, so why? Because we have generated from this code. Okay, and we have just simply created a function like a login button function. When user click to login, we are just simply validating whether username and password is correct or not. If it is correct, then we are destroying the window and we are opening the next window. Okay, the home screen. So I hope you understood. Like let me explain you the folder structure as well. Okay, so this is the audio. We are having the audio file. Okay, and this is the hard cascade file, which is basically consist of model for face detection and eye detection. This is the random images available, and this is the model data. Model data is nothing but YOLO weights. Okay, this is the resources, the wheel image, and this is the text for the OpenCV, and this is also, and this is the YOLO backend. This is the YOLO architecture. Okay, and this is the test video, and this is the model, our steering model which we have trained. Okay, and this is a data set. Data set is nothing but the daily files. Okay, daily model. This is a notebook. I think I have shared you because just now I have downloaded this file. I forgot to send you. I will send you it again. Okay, okay, and this the same Gmail file is there. So basically in this we have used ya Gmail library to send the email, okay, to the contact. Okay, and similarly, if you go to algorithm.py, so algorithm is something where we are processing everything like a backend drowsiness detection, steering wheel, and this lane detection and everything. Okay, and this is a constant.py file which is for constant, and this is a distance estimator. This is a rough file. Okay, and this is a phase detector. Just these two are temporary file. Okay, you no need to, you can delete as well. And this is the home screen code. Okay, and this is the main UI support and Gmail start drowsiness. So like that. So yeah, so this is about your project. Okay, do let me know in case any doubt or any issue.
Thank you friends for watching my video. If you are new, then subscribe channel and share with your friend. Thank you.